Hello and welcome to the EEPROM 9, and today's subject is not this lovely RC thing, but it is related in the fact that it's for the project. But what we're looking at are these lovely little things. I was going to do a whole thing where I was going to solder this one up because it's basically the same circuit as a lot of these, but yeah, I don't have time to do that right now. I got too much other shit going on. But we have a schematic. So, what are these strange little motor devices? Well, let's take one apart and show you. And they basically all use the same topology even when they use different chipsets. They're usually clipped, glued, or held together by some form of sealant, so they come apart pretty easy, run on 3 wires, and basically, they're a linear actuator. They're your headlight adjustment motors. And no matter which one you take apart, they basically are the same thing. You know, a lot of them will have a variant of the this particular chip. Some of them will have different chips, like this one. The one that has a different chip is already in use, and the chip is, if I can see it, it is a TDA 3629T is the 16-pin version, and the 8-pin version is the A. But there's a nice gear mechanism. You've got a variable trim pot so it knows where the linear actuator is. And just a standard DC motor. And a mixture of metal and plastic gears. You know, because let's be honest, the little plastic gears around the motors always snap. If you watch any of Randy Rain's stuff, you will see that's a very common failure mode on these little geared motor systems. So because these are used in a car, the gears are actually metal. And their operation of like the circuit is actually pretty simple. We'll go through that, and then we will put one, and then we will fire one up and show you what they do, basically, and give you a rough thing on how to power them. So here's our schematic. So as you can see, they are surprisingly simple because they almost have probably some kind of internal H bridge. You know, they all seem to have, you know, motor capacitor. And they basically hold to this topology. Every single one, even the ones that use different variants of this chip or different chips entirely. So the signal goes in through the 30k resistor and into the set pin of the chip. That then goes to the actual trim pot, that's a 3k trim pot in this case, that is used to tell the position of the actual linear actuator, based on how far it's pushed up and down. One side of it goes to negative, the other side goes to positive. It's pretty standard. You've got the main filter cap for the negative and positive. You've got reverse polarity protection diode. So if there is a fault, then there's that. And of course a point where it goes between the FB, because the this little one, this trim pot goes to the FB on the chip. This one goes to the actual set to determine the position. And what I've noticed is you need about 100k between either positive or negative to make it go fully in or out. If you go between those values, you can get it to go part way, and if you just short them, they really do nothing. So they're quite interesting, simple circuits. The one thing that eludes me with this particular circuit, and it's actually in the main schematic in the data sheet, and this is the 8-pin version, it's basically the same chip. One of these, this one has a dip, this version, the dip version. The rest are all SMT, and then one uses a completely different chip. But they're great. They're little linear actuators, so you can use them on robotics projects and stuff. Like, for example, I'm building a red dwarf scutter here, so I'm going to use that for the claw opening mechanism. And then, of course, there's 2 servos that do the up and down and that movement. So that's pretty cool. So there's a good use of it, you know. They're super easy to drive. They don't require microcontrollers, and I can prove that here. So let's disconnect the locomotion of the same robot. And we connect up the positive, negative, and signal. So white signal in this case. Just make sure that's in view of the camera. They take standard 12 volts because they're from cars. They do actually go up more. The one thing that confuses me with this diode is, well, it's kind of set up wrong to be reverse polarity protection. Because there's already that one there doing that. It's like literally... The only thing I can think is it has 2 possibilities. It's either basically the equivalent of a... what's the term? The protection diode on the MOSFET to stop noise coming back from the car power line. You know, high voltage spikes coming in and nuking the chip. You know, transient suppression diode, I believe the term is. Or maybe, and I'd have to remove the diode to confirm this, it's a Zener diode that basically caps the voltage in the very brute force, not particularly elegant way that Zener diodes do just that. That's the only 2 things I can think it can possibly be for. Either transient suppression to stop high voltage spikes blowing up the chip, or the Zener diode to just stop the chip being overvolted if there's a fault with the battery and whatever, and the alternator goes up super high, which does happen from time to time. So we turn the power on, and what we do is we put one finger on the positive, and this is where using non-insulated probes would be good. And you might be able to see that it's extending, because I'm basically using the resistance of my body, because, well, that's just an easy way to test it. I've tested it down to about 100k seems to be the maximum to get it to go up. And if we do the other way, negative, it will retract back in. Which isn't very easy to see. So we'll do another one. But yeah, these are really interesting, easy things. And it doesn't seem to matter the manufacturer of the car. They're all basically wired in the same way. Let's do this one. This one might be easier to see. And mount him sideways. I think blue is signal in this case. So as you can see, the white motor, the white linear actuator is extending out. These are quite slow and noisy, but they have a lot of torque to them. And for whatever reason, the hobbyist electronics community does not seem to be aware of these things' existence, because, yeah, you just look up stuff to do with people hacking these for robotics projects and see how there's basically nothing. And then if we do it between negative, it goes back in. So it's even consistent in the direction it goes. So you can literally do these with like relay operation and whatnot, which is how I'm going to do the scutter one. I haven't figured out how to interface it to this though. That's a problem yet to be solved. But yeah, that's these headlights, dipping headlight that make the headlights dip up and down. Linear actuator motors. They're very good for hobbyist projects. You know, this is why you need to get down to the scrapyard and pick stuff up like this. I need to make another visit to that scrapyard, actually. It's been far too long. And see what other wonders await me inside. I want to get hold of a few of the coils for the ignition, because there's some fun things you can do with them as well. But that is all. And yeah, this is window... linear actuator motors are going to be the main drive. I'm just going to 3D print some new pulleys to go on these. Thanks for watching.